All right, we're going to talk about combinations. So a combination is a selection of k distinct objects from a total of n objects where order doesn't matter. So the number of combinations, n, so we take out of n total objects, we're going to take k. Another way of saying this is a combination is a subset of k elements of a larger set of n elements. So we have a large set of items or things, and we only take a subset of those, and order does not matter. The number of combination of k objects taken from a total of n objects is given by nck. Now, in math, you'll often hear people say n choose k. So we're choosing k objects from 10 or from n. So n, so I'm just going to cross this out. N choose k is equal to n factorial divided by n minus k factorial, k factorial. Another way of thinking of it, if you look up to this formula, n choose k is equal to the number of arrangements in a permutation divided by k factorial, which would be simply the number of ways you can organize your subset k. So you're taking out the repetition. All right, so below is a picture lock. Mathematically, should be called a combination lock, right? Is this a combination lock, or is it more of a permutation lock? Great question, I say. So I am just going to say, suppose this has the code 10, 21, 19. If it was a permutation lock, order matters. That is, you'd have to choose 10, 21, and 19 in that order. If it was a combination lock, well, you could say, well, that would definitely open it. Or sometimes I enter this, or sometimes I put 19 first. Really, the order doesn't matter of your elements. Another example of I hope you understand. So when we say order matters, order does matter. And order matters in some items, such as words. Order matters. Which letter comes first? A combination, sometimes order, or in a combination, order doesn't matter. So I'm just going to give you maybe Lotto 649. So what is Lotto 649? Lotto 649 is just, they have 49 balls in a big drum. And they call it, by the way, it's 649. And really, you choose 6 balls from 49. This is actually a combination. What happens are people choose 6 numbers. Uh-oh, what if these are the winning numbers? Anyways, people choose 6 numbers. And as they draw the balls from the drum, you just have to match numbers. Now, 1 can come out first, and then 27, and then 4, and then 16, and then 29, and then 7. So order doesn't matter, so it's a combination. If it were a permutation, you would have to come out with this select order, which would be astronomical probability. Anyways, let's move on. Example. By the way, this should be called a permutation lock because order matters. Let's do the next example. In the year 1977, I was selected to choose the last name of my family. I was to select 5 distinct letters from the alphabet, from 26 letters. I chose the 5 letters M-O-R-I-N. When you read my last name, Morin, is this a permutation or a combination? Well, here, the last name Morin is actually a permutation because the order of the letters matter. Now, hypothetically, if our brains developed so order wouldn't matter, you could call me, or I could spell my name like this, and those two would be indistinguishable, right? So that this Morin is a permutation. If you could mix up the letters, then it would be a combination. So suppose the name Morin was not typed in as M-O-R-I-N. What would this mean? Well, in real life, these two are not the same. They're distinct from each other. So these would mean that they're different objects. So if you mess up the order, you're talking about something totally different. Sort of like the combination lock. You need to get that order correct. All right. Calculate the number of combination of 4 digits made from the digits 1, 2, 3, 4, 5, 6. We're going to calculate the number of combination of 4 digits made from the digits 1, 2, 3, 4, 5, 6. For all we know, we could call this A, B, C, D, E, and F. They are just objects. So we are going to figure out combinations of this. And how many are we selecting? 4. So N, we have a total of 6 in our larger set. We have a total of 4 in our subset that we're collecting. So this would be 6, choose 4. And we could use our calculator, or we could say that it's 6 factorial divided by 6 minus 4 factorial divided by 4 factorial. But in my calculator, under the math menu, I can go to probability again. And lo and behold, number 3 gives me NCR. So I'm going to choose that one, number 3, NCR, 6. And what I get is there's 20 different combinations. Now I'm just going to talk about 20 different combinations. Like, these two would be considered one combination. They're indistinguishable. Order doesn't matter. So suppose